Hi, in this video, we will see what is upper tail test. This is one-sided hypothesis test, and in the last few videos, we have gone through two-sided test. In fact, in the last video, we also saw left tail test, and in this video, we will see the upper tail test, okay, or the right tail test. It's also known as right tail test or upper tail test. Both are fine. The mean, variance is known, so that's one thing. If the variance is not known, then obviously we'll have to use something else. And what it is used for is that to compare two means, but not for the equality, but it's all about whether it's something is less than the mean of one sample is less than the mean of another sample, or any threshold. Well, we are interested in knowing actually what the mean of the first sample is less than some sort of a threshold. Okay, and threshold here is mean of 2. It's coming from another sample. We do not have to know anything about that. It's just a number that we know, and we want to compare the mean of the first sample with that number. And the null hypothesis here in this case is that the mean of 1 is less than mean of 2, less than equal to. Okay, and here the mean of 2 is the upper limit, right? And alternative hypothesis is that the null hypothesis is not true, right? It's the opposite of alternative. So basically, alternative hypothesis is the opposite of null hypothesis. Now, the test statistic, as you know, in other hypothesis test, is basically the difference in the mean with divided by the standard error. So you have mean 1 minus mean 2 divided by standard error, and you standard is nothing but here is standard deviation divided by square root of n. N is number of observation. Standard deviation, is just square root of the variance, right? So that's something known to us, because that's why it's called known variance. So that's kind of a test. We'll take an example. It's a very easy example. It can be used in many applications. So we will try to use the upper tail test to compare two means, to compare if the mean of one sample is less than the threshold. The threshold is coming from another sample, and we know the standard deviation of the sample one, the first sample, and we also know the number of observation in that sample. We would like to do this hypothesis test with 95% confidence level. So 95% confidence level corresponds to 1.65 and negative 1.65. Okay, so if it is if the test statistic that you find, right, using this formula, right, is falling outside this boundary, like negative 1.65 and positive 1.65, if it is falling outside of this boundary, then we reject the null hypothesis. So in that case, the p value, right, in many other tests you might have come across, p value is then less than 0.05. At 95% confidence level, you reject the null hypothesis. Otherwise, you accept the null hypothesis, right? So that's the criteria here. And where these values are coming from, like 1.65, 1. This is theoretical distribution, t distribution basically. Okay, if you actually see the table, theoretical table, and you'll find that at 95% confidence level, these are the thresholds. So that's how you it's nothing but actually 1.65 standard deviation of from the mean. It's as simple as that. If you're familiar with that sort of a distribution, the bell-shaped curve, which is very yeah, it's a slight different from the normal distribution, but yeah, still a bell-shaped curve and pretty symmetric across across both sides, negative and positive side. You will see that if your data is falling outside of 1.65 times standard deviation from the mean, then you reject the null hypothesis and you accept the alternative hypothesis, right? It does, that sounds a bit mechanical, but actually, if you actually try to go through the theory a bit, it will come. Yeah, you can understand a bit better. Anyway, so here we have mean one and mean two, and we have sigma. Sigma is nothing but the standard deviation. Mean one is given, it's slightly higher, and mean two is also given. And sigma is basically sigma of the mean of the sample one. And n equal to 30, that means number of observation, that's also coming from sample one. Mean two is just a threshold. We like to compare with this, whether mean one is less than equal to mean two or not. Okay. So then we will calculate the uh, test statistics in this case. So mean one minus mean two divided by sigma and square root of n. It's as simple as that. Actually, you can also use some built-in functions for this, but you can also calculate the t statistic by yourself. Okay, so let us run this. All right, so now it is run. You can also calculate using hand. You don't even need R actually for that. Comes out to be 4.5, which is greater than 1.65, right? Question is, why is it okay? Let's first conclude, and then I'll talk a bit about how is it different from the left tail test, because in the last video we saw left tail test, right? So here we see the value is 4.5, which is obviously greater than 1.65. So we reject the null hypothesis that mean one is less than equal to mean two. Uh, Alternative hypothesis is that it is greater than mean one, and which is what we expect, right? Meanwhile, obviously, we see higher. How is it different from the left tail test or the lower tail test? Well, lower tail test is used to compare whether something is greater than the other thing, right? If the mean of a given sample is greater than the threshold, where it is, but it is exactly opposite here, where the mean of a given sample is less than equal to the mean of another sample. So that's basically is the difference. It's exact opposite of the left tail test. And this is, I mean, one side test is very is useful when you want to compare. We want to compare which value is greater than which value is greater. So if you really want to do that, so one side test actually helps. Two side test is useful when all you care about is equality, whether two means are equal or not. You don't really care about which one is greater than the other. Okay. You don't really care whether mean one is greater or mean two is greater. You really care about whether they're equal or not. That's what you only care about. In that case, two-side test is enough.